Welcome to the simple harmonic motion of a pendulum video. In exercise 1, we'll be setting up the apparatus.
Begin with a stand and bar and attach the rotary motion sensor. Cut a string to an appropriate length and tie it around the sensor. Tie the other end to a mass.
Open Data Studio and select Create Experiment. Click on the first digital sensor slot and select Rotary Motion Sensor. Change the sample rate to 100 Hz. Click the Rotary Motion Sensor tab and change the resolution to high.
In exercise 2, we'll be investigating the effect that varying a pendulum's length has on its period.
In Data Studio, go to the first Measurements tab and enable Angular Velocity. Create a graph of angular position versus time. Press Start and set the pendulum in motion. You may find the Autoscale button useful. Capture about 20 oscillations. Repeat this exercise for at least 10 different lengths.
In exercise 3, we'll be investigating the relationship between angular position and angular velocity.
Drag the angular velocity into your graph so that both angular position and angular velocity are visible. Uncheck any previously displayed data, press Start, and capture several oscillations. Note the phase difference.
In exercise 4, we'll be determining how the period depends on the variation of gravitational force by using a rigid pendulum arm at various angles.
Plug the photo gate into a digital channel. Arrange the photo gate such that the pendulum bob passes through it. Make sure to arrange things such that the pendulum doesn't hit the photo gate stand. It is very important that the metal thumb screw does not pass through the photo gate to avoid multiple triggers for each pass.
In Data Studio, click the digital channel and select Photo Gate and Pendulum. Click the Constants tab and enter an estimate of the pendulum width. Create a graph of period versus time. Press Start, set the system in motion, and record the periods of about 10 oscillations. Note that if only one end of the pendulum passes through the photo gate, your periods will be off by a factor of 2.
Repeat this exercise for at least 10 different tilt angles.
In exercise 5, we'll be investigating the effect that varying a pendulum's mass has on its period.
Design a pendulum that can carry different masses. Try to ensure that all the masses remain rigid as a group to avoid coupling effects. One possibility is to add masses to the variable G pendulum as shown. Another possibility is to hang several hooked masses from the same loop of string such that they rest against each other.
Heisenberg is out for a drive when he's stopped by a traffic cop. The cop says, "Do you know how fast you were going?" Heisenberg says, "No, but I know where I am."